Hello everyone. Today let's discuss more about Numpy. In our last classes, we have discussed how to create different dimension arrays, how to stack them, how to do indexing, and how to concatenate with same dimension array. And if we do have the different dimension array, so today we are going to talk about some other functionalities that we can apply on arrays. First, I'll initiate with how to apply for loop on any array on any dimension of array. So let me create sample arrays, which is 1, 2, and 3 dimension. So here it is. I have just copied that code. So I have created three arrays. Let me import NumPy as well. X1, X2, and X3. 1, 2, and 3 dimensional array. So you know how the basic functionality of for loop that we apply on any iterator or anywhere in core Python. So the same thing we can do here with NumPy array as well. How you'll be doing with one dimensional array? Let me call one dimensional array x1 here. So let's say I want to apply for loop here. It's quite simple. For let's say I in, and the name of my array is x1. I'll simply print it, and here it is. So it will just loop out the same as we used to do with list or any iterables. And the same thing you can apply for the two-dimensional array as well. My two-dimension array is x2, and I'll be writing, and I'll simply print it. Here it is. And you say that we have applied for loop on two-dimensional array as well. So where is my two dimension? Yeah, 4 rows, 4 columns, right? And here, let's say the same we can apply on three-dimensional as well. Let me showcase you. And this is I. Here it is. So there is no changes at all. And for example, you want to do something different here. Let's say I just want to create a simple series of any dimension of array. So I can do that as well. So there will be bit changes in looping. Let me try with 3 dimension only. For example, I'll be doing for I in, and the name of my array is x3. And then I'll apply another for loop for, let's say, j in, and here I'll be using that value which I use for first for loop, which is I. And then again I'll be using loop inside for loop for j n, sorry, that will be k and j, and I'll simply print k. And let me run this, and you see that the entire sequence that we have generated from x3 will be here. In case you want to utilize it and you need to do some different thing with this, so you can simply iterate it like this as well. And in Python, we already have some predefined functions which help us for the iteration as well. Let me showcase you the difference between these two functions altogether. For x2, for example, two-dimensional array, this is a two-dimensional array. Using for loop, I'll be writing it for I in x2, print I, and it will loop out the entire array. And in case I want to do the same thing with a predefined function of numpy, so how I'll be doing this? I'll be writing, let's say, for x in np dot and iter. This is basically for iterating the arrays. That's a function available with this. And I'll run it. Not here. And I'll print basically x. Oh, no, not array. The array name is x2. Here it is. Yes. So here we have basically what we did. We have iterate all the records that we do have in this array using editor. And for example, let's say we have something. For example, you want to iterate this with their indexing as well, and you want to iterate with some interval, and you have to give us a different starting point, let's say. So you can do that as well. Let's say I'm giving a different starting point here. For example, this x2, how I want to start it. Let's say I'll be using index parenthesis here. So I'll start from 0 in terms of rows, and let's say every second column I want to do something like this. So yes, I can do that as well. So that is also possible. Let's say you want to iterate it, and with any interval or with any starting point. So you can use index parenthesis inside this function, and you can change as per your requirement, right? So you can do it like this. And for example, you want the index and values all together. That's what also we can do. We'll be using a separate predefined method that is available in Numpy, and the name of that method is nd enumerate. I believe you all are aware of the enumerate function that we have in core Python as well. So we can use it in Numpy. Let's say for I need two temporary variables, j n np dot enumerate. This one, yes, this one. And the function that I want to apply, array that I want to apply is x2. And let me print these two variables all together, print I and j. Let me run this. You see, what is the difference between and enumerate and editor function? First one, editor is just to for the iteration of the records that we do have in array, and enumerate function is just to get the index and values all together. So we can check the position of every element as well. Let's say 19, it's at 0 row 0 column. Let's say I want to check this one, so this is at 1 row 2 column. So you can particularly find the value and the position all together for any dimension of array after applying any enumerate function. So this is very useful in case you want to apply it anywhere. Yes, you can do that. Now I'll be talking about some other functions that we occasionally use in NumPy, and the name of the function is array split. Although we have already covered this split, but here I'll be using some other methods as well. Array split, how we do it. For example, we have this x1 array, yeah, and we want to split it, and we want to split it and store it to a different position. For example, new array, I'm giving this a name new array, and np dot array as a method which I'm going to apply for split, np.array underscore split. And which array you want to split? I want to split x1. And how you want to split? I want to split in three parts, let's say. So I'll simply print these three parts all together here. So just to showcase all, and that will be a 0 index. Let me copy and paste for 1 and 2 as well. Here it is. So I'll change this index as 1, and then this will be 2, right? So let me run this, and you see, and for the 0, and it has splitted array x1 into three parts. The first one is 517, you can check it out, and second is 1119, and third is 1818. So you can use np array split for doing this part as well. For example, you can do the same thing for let's say two-dimensional array. Yes, you can do that as well. Let me apply on two-dimensional too. So let's say I'll be writing new one. I have given this name, for example, and then np dot array split, and I want to split two-dimensional array which is x2, and let's say I want to split into three parts or whatever you want to do, and then I'll simply print new one where I have stored this one. So you see that we have splitted x2 into three parts. Here it is, right? For example, uh, uh, you want to do, for example, you want to split bases on, let's say, for a specific axis. So you can do that as well. You have to define the axis. Let me call, I'll be applying on this thing on three-dimensional array so that you can easily understand. This is x3. I'll be giving it a name new x3, and how I'll be using np dot array underscore split, this one, and then the name of array which is x3, and I want to split into three parts, and based on axis, let's say 1. So once I'll run it, let me print new x3 as well. Here it is, new x3, and I'll run it, and you see that it has splitted the x3 in three parts and based on axis 1. You can check it here. You try to understand based on the x3 array. In case you find any confusion that how they have been splitted, you feel free to write me. I'll explain you that part. Okay, so let's say you want to do this for x2. Let me try this too. Here it is. Yes, you can do for two-dimensional as well, right? For example, you want to do for this is basically a split based on axis. The same thing you can do by using h split and v split that we have discussed in a previous class. We can do that as well. And let's say we have an array and we want to basically apply certain conditions. So we have a where function here. We can apply that where function as well. So what it will do, uh, whatever we have, whatever we will mention in that where condition. So let me give you an example so that I would be able to explain you. Will be using, let's say, this is an array x1, and I want to apply certain condition on this. Let's say np dot array, right? No, I just need to apply condition directly. np dot where, and the array name is x1. And for example, let's say modular operator 2. I just want to divide by 2 and I just need even numbers, for example, right? So not I will divide the entire records that we do have in x1, and I need the value as 0, or let's say the value as 1 for odd and even. This case will for odd and even. For even and odd we can apply both. Let me store it to a different location, new x1, let's say, and let me call new x1. Here it is. So you see that these are the records that we can, what it has given. It, this basically showcase the index. Might be you guys confused with the records. No, it give you output as index number. Output will be a index number. So here you can check that in this array at 0 index, that does not give output as 0 after applying this condition. And same goes for 1, 2, 3, and yes, for 4 and 5 we satisfy this where condition. So that's why it has given that output for us. Sometimes we get confused with the value. No, this is not for value record, this is for the position. And same thing we can apply, let's say, for, let me change this a bit. I believe you clear with this. You can apply for any dimension. And let me run or call x2. So here it is. It has given you the indexes that satisfy this condition. 0 index, yes, this satisfy this condition. 1, 2, and 3. 4 and 5, which satisfy the previous condition, is there in this output. And for this, a modular operator 2 equals to 1. This satisfy. So now we'll talk about a different function, which is, let's say, search sorted. That function is also there, and we'll be talking about sort function. Search sorted, right? And then we have sort function, just to sort any values that we do have in array. So let's say we have this x1 array, and we want to basically find the indices where that particular element should be inserted, so that it can maintain a sorted order, for example. So for example, we let's say we write it something like this: np dot search sorted, and we have this x1 array, x1. And let's say I have given any value, it can be any value. Here I have given, for example, 4. So once I'll run it, it has given me 0 index. Why? Because if you call x1 index, if you insert 4 at 0 index, then only it will maintain the uh, for example, the order, the sorting order, basically it will maintain. And simply, let's say if you give any value which is larger than this last index, let's say I have given 24, or what is, which is greater than 18. So it will give me the last index, let's say 0, 1, 2, 3, 4, 5, and 6. So it should be inserted to the sixth position, then only we would be able to maintain the order. So this is how we can use search sorted function. And on the other hand, let's say we want to apply a simple sort function. Yes, we can do that as well. So we'll be writing np dot sort, and then the array, whatever you want to sort. So you can do it for any dimension of array. And for example, there are few handy functions that we do have in NumPy. Let's say we have any array, and we want to basically find the maximum value that we do have in that particular array. Yes, we can do that. And the minimum values, or you can say the average, or you can say the standard deviation. There are few functions we do have that we can directly apply on with NumPy, and it will be very helpful us to get the calculation or the mathematical calculation for that particular array. So let me use this. For example, I have already created array which is x2. Let me apply this on x2, or let's say x3 you can apply, or x1 you can apply. Now let's say we want to find out the maximum value that we do have in this array. So we just need to check it out, and then only I mean, it will take some time to calculate that. But in NumPy we can do it directly. For example, this is the array, and we simply want to find out the sum of, or let's say the max of this array. So we'll run this function, and we can get that this is the maximum value that we do have in x2 array. And for example, the same way you want to check the minimum value, so you can call the min function. Here it is. So you see that 5 is the minimum value to this entire array. And let's say we want to check the mean or whatsoever. So I have that function too. Let me run this. So this is the mean. How we calculate it? We just add the entire records that we do have in this array and divide by with the number of occurrences, that the total number of records in this array. So this is for mean. Let's say you want to do the sum of this array as well. Yes, we can do that. So you can apply this sum function, and this is the output. Or let's say the standard deviation you want to do, or you want to sum up this array based on a particular axis. So here you can apply axis as well. So how you will be writing that syntax? Let's say x2 dot sum, and you want to sum it for a particular axis, so you can apply your axis here. So this will be a syntax: dot sum and axis equals to 1. So 1 is for row and 1 is for column, 0 is for row. Let me give it here. Axis 0 is for row and axis 1 is for column. So we can apply as per our requirement. Axis 1 is for column. So here it is. Apart from this, let's say we have any two functions with same dimension and we want to add those functions. Yes, we can do that as well. And let's say we want to multiply. So we can, yes, we can multiply two. There are multiple options to do this. You can simply apply the mathematical functions x1 plus x2. Apart from this, you can use a predefined function sum as well to do this calculation. So there will be no changes at all. So you can write np.add, np.subtract, and the same way you can write x1 plus x2. And one more thing I just want to tell you, let's say we have any array, and you know what exactly the definition of any array, it's a collection of similar data type, right? Collection of similar data types. That's a very basic definition that we all are familiar with. Now let's say we have any array, we want to change the record that we do have to any specific position. So how we can do that? We already have that option that we will find out the index, and then we can insert that value to that position. That's what we can do. But we have to be very careful while doing this. Let me showcase you an example. Here is your two-dimensional array. Let's say for any specific position, let's take x2, and let's say 1 row and 3 column. So what will be the output? That is 14. Here you can say 1 index row, which is this one, and the 3 index column. So 0, 1, 2, 3. So that will be a value. And let's say we want to replace it to a different value. For example, I want to give it 20, right? So let me call x2 here as well, and you see it has been changed as 20. So you can change the value of any index after passing the position. How we extract, the same way we can change that particular record after finding that particular position. But you have to remember one thing: if you can apply the same thing with a float value, let's say I want to do it 2.5. So for this position, I want to make certain changes with a float value. So it will take only the integer part. Why? Because in any integer array, we cannot add float value. Otherwise, it will change the property of that array. That is the integer array. As per the definition, it holds the similar data types. But if we are adding float value to the integer array, so it will take only the integer part and it will truncate the float value. So you should remember this thing, that it will add only integer value. But in case you have a float array, yes, you can directly add the float value to that. And if you are adding integer to that, so it will take, let's say, 2.0 to this one. So you should be very careful for this part. So these are some important functions in array that we use on let's say daily basis. So apart from this, I remember there is one absolute function as well, which converts any array to the positive value. I have to create a new array to do this. Let's say x4 and np.array. I have created this and I have passed some negative value to this. Let's say 6, 8, and 5, for example. So here is x4, and you want to convert as positive. So you just simply call this a absolute function, and you can apply it to x4, and it will convert to a positive value. So you will be using this function to do this. And sometime that we understand that array we make for mathematical values only. No, this is not. We can create an array, any array with textual data as well. Let me create that for you. np.array This is not for mathematical numbers only. Let's say I have created any array, for example, this is red, and let's say white, and let's say I have given a different number which is green. And here it is. We have create array with textual data as well, and you can apply sorting here too. For example, you want to sort this array, it will take into alphabetical order. That is E double R, and here it is. It has shorted to alphabetical order. So this is what you can apply. So these are few things that we use on daily basis. In case of any confusion, you feel free to write me. I'll come up with our next class. Till then, take care. Bye bye. Thank you, everyone.